Okay, proof concepts to know. So this just focuses on proof concepts, and then we'll work our way into like the proof setup. So first things first, and you've seen some of this already. First one is midpoint theorem. It says given that M is the midpoint of KL, so here is segment KL, and it's saying, okay, M is the midpoint. What can you prove from that? Well, if M is the midpoint, I can prove that KM is congruent to ML. And that's what it's looking for. So since M is the midpoint, segment KM is equal to ML. Okay, and then definition of segment bisector. So a segment looks like this. It's like a line segment with like two endpoints. A bisector breaks something in half, breaks in half, like two equal parts. So a segment bisector would break a segment into two equal parts. So here it says BD bisects AC. So here's the segment bisector. It bisects this segment into two equal parts. So therefore, AB would be congruent to BC because it's a segment bisector and it breaks it in half. So AB is congruent to BC like that. Okay, the next one, it says reflexive property. Here I see two triangles. I don't know if you see it. So pointing it out, I'm looking at this as two triangles. And then the two triangles have this shared side in common. And so when we're proving triangles congruent, we have to prove that this is equal to itself, and that is reflexive property. So we can say that JL is congruent to JL, because it's literally the same line, but we call that reflexive property. So the shared side here. Shared side for the two triangles. Okay, and then these down here refer to angles. So reflexive property with angles is the same thing, like the same angle is equal to itself. So maybe angle B is congruent to angle B. Let's see. So looking at this, you may see different things, but something I see is that there are two triangles. So there is a triangle here, and there is a triangle here, and they kind of overlap. And where they overlap is at angle B, right here. So they overlap here at angle B. So therefore, in these triangles, angle B is equal to angle B. Okay. Then the next one, right angles theorem. This came up in Alex last week too. Right angles theorem, what it has to do with is all right angles are congruent. All right angles are congruent. So if you're told you have two right angles, you can say they're equal to each other. So given is this picture here with two right triangles. They both have a right angle here and here. So therefore, angle G is equal to angle K. Congruent to, however you want to say it. Okay, and then angle bisector. So an angle is like this, right? And then a bisector breaks it in half. So like an angle bisector would break the angle exactly into two equal parts. Here it says BD bisects angle ADC. So BD is the angle bisector. It bisects this angle into two equal parts. So we can say that angle ADB is congruent to angle BDC because of definition of angle bisector. So these are situations that are going to come up in proofs. So for example, if it says BD bisects the ADC, then we can say that these two angles are equal, and the reason would be definition of angle bisector. And then vertical angle theorem came up a lot last week too. Vertical angle theorem, vertical angles are congruent. Vertical angles are congruent. So in this picture here, this angle equals this one. So we get angle NPL is congruent to angle MPO because they are vertical angles and vertical angles are congruent. So, can you take your headphones off, please? Okay. Okay, and then over here gets a little bit more in depth. It says parallel lines and transversals. So parallel lines look like this, and then the transversal intersects those parallel lines. And what happens is you have a bunch of like congruent angles when this happens. So like essentially all the obtuse angles here are equal to itself. So all the obtuse angles are equal. And all these acute angles are equal to each other as well, like this. And so we're going to look at how this would come up in proofs for these triangles. So here it's talking about alternate interior angles, and it shows two parallel lines, like this little symbol shows that this is parallel to this. So this line here is parallel to this one. And then these lines become transversals. So this is a transversal. And alternate interior angles are equal. So this angle is congruent to this one. So angle TSR is congruent to angle TSR is equal to QTU. Because alternate interior angles are congruent. And then for this line, this angle is equal to this one. So angle UQT is congruent to URS. URS. Because alternate interior angles are equal. So then you have like angle, angle, and all you need is one more piece of information, and you could have angle, angle, side, or something like that. Then for this one here, we have parallel lines right here. And then all these angles are transversals. We're going to focus on this line right here, or all these lines are transversals. We're going to focus on this line right here, and alternate interior angles are equal. So like this angle is equal to this. Angle BDC is congruent to angle DBA. Okay, then here corresponding angles theorem. Corresponding angles are equal to here angles are equal. So like what are corresponding angles? So just to review, when you have parallel lines and a transversal, these would be corresponding angles, like this angle and this angle right here. And there's a lot of different corresponding pairs, but this is one example. So given, like this is the given, it shows a parallel line here and a parallel line here. And then this would be the transversal. And so since corresponding angles are equal, we can say that this angle equals this one. So we can say that angle VSU equals angle WUT. Okay, and then down here, we're going to apply some of these concepts to these drawings here. It says, decide whether you can use side, 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 or side angle, side postulate to prove the triangle is congruent. It's the same thing we were doing last week. Either side, 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 or side angle, side this time. If so, write a congruent statement and identify the postulate. If not, write not possible. Okay, so for number one, we have angle, side, side, angle, side, side. that would make ASS, which isn't a congruent statement. So this would be not possible. Like they might be congruent, but we can't prove it. Okay, and then number 2, we have side angle, cool. Then the shared side is equal to itself because of a reflexive property. So we can prove that EF is congruent to EF because of reflexive property. And then you have side angle, side angle, side. Okay, and number 3, you might be saying, hey, that's side. You are correct. Before we get there, though, we want to prove that this is equal to itself. KO is congruent to KO because of reflexive property. And then we can say it's congruent because of side. Then number 4, we have angle, side, and then the shared side would be in common. Cool, but that would give us angle, side, which isn't a congruent statement, so not possible. There is one situation where ASS does work, and that's with right triangles. So just make a note, right triangles. So let's say we have right triangles right here. They have that, of course, the right angle in common. And then they have a leg in common and then the hypotenuse in common. So we have angle, side, angle, side. So ASS does work for right triangles. However, we don't call it ASS. We call it hypotenuse leg. Hypotenuse leg. So it has a hypotenuse in common and a leg in common, and of course that right angle in common. And we can use that congruent statement for right triangles. So if you come across the ASS, check and see if it has a right angle, because then, yes, you can prove congruence there. Okay, then once you got that down, we're going to flip not to the next page, but the page after that. So we're going to flip here. Not this one, because this one should be filled out from when we did it before. And then we're going to flip here. Restart my recording soon.